video, we are going to discuss the classification of signal. That means how the signals are classified. That will be discussed here. Basically, signals are classified into 6 different types. Here we are classifying the signal according to the nature. The types are continuous and discrete time signal, deterministic and random signal, even and odd signal, periodic and aperiodic signal, energy and power signal, and lastly, real and imaginary signal. First, we will consider continuous and discrete time signal. We can broadly classify the signal into these 2 types. Now, first we have to consider continuous time signal and after that discrete time signal. The signal which are specified in every values of time, which is here t, are called as continuous time signal. Now I will take one very basic continuous time signal. In this graph, y-axis is always represents the signal itself and x-axis is for independent variable time, which is here time. The signal having an amplitude A, for example here, when time t equals to 0, then the signal starts to decline linearly with respect to change of time, and it becomes 0 when time t equals to t1 for the positive side. After that it remains 0 up to which the time tends to infinity. Actually, the signal always inclines with respect to time because you cannot reverse the time. But here, for understanding the concept we are considering here, that the signal is declining with respect to time. Similarly, the signal xt is again declining for the negative side with change of time, and it becomes 0 when the time t equals to t2 here, and after that it remains 0 up to minus infinity. This is an example of continuous signal because we can see the signal is defined or specified for every value of t from minus infinity to plus infinity. Let's consider some other example of continuous signal. The first example show you a sine wave of amplitude A. In the second example, it is an example of square wave. It is a example of square wave. And the third one is a triangular wave. It is a triangular wave. In all cases, waveforms are denoted in a continuous way. That means there is no cuts or breaks in between the signal when it flowing with changing of time. Hence, it is called as continuous time signal. Now, if we want to define any continuous time signal, it can be represented in the equation form also. For example, consider this signal. For determining the signal expression for a continuous signal, we have to find out the time period of this signal. It is also called fundamental time period, T. For calculating T, we have to consider one complete cycle. That means it is the complete cycle when the wave is completed. Here it is one complete cycle because the total signal is created by continuous repeat of this cycle. You can see here the total signal is just a repeating of this cycle. Hence, this time period, that means the time required to complete this one cycle, is called fundamental time period, which is here denoted as T. Now here T equals to 2. You can see here I am leveling here the point as it is 0, 1, it is 2. So therefore T equals to 2 here. Now as it is a sine wave, the equation of sine wave would be represented as xt equals to a sine omega t plus phi. Again I am repeating, xt can be represented as by expression a sine omega t plus phi. Here a is the amplitude of the signal, omega is the angular frequency, and phi is the phase difference of any signal which is calculated with respect to another signal. Now here as you can see it is a, let's a equals to 2. So I am writing here a equals to 2 sine. Now we should also know one another formula, omega equals to 2 pi by t. It is the formula to calculate or the relation between angular frequency and the time period. So omega equals to 2 pi by t. Now here as t equals to 2, so we can write here omega equals to 2 pi by 2 or omega equals to pi. So by replacing the value of omega, here we can write pi t and we write or we imagine here phi equals to 0. So it becomes 2 sine pi t. So one thing you should remember that here I am assuming that phi equals to 0. That means there is no phase difference between the signal. But if there is any phase difference, you must be calculate that phase difference and you can put this value at that equation. So likewise, we can express the equation of any continuous signal that can be clearly defined for all instant of time. Now I will talk about discrete time signal. A signal is specified at discrete time interval, or you can say discrete value of time are called as discrete time signal. The representation of discrete time signal is written here x within the third bracket of small n. Here n is the integer value, whereas for a continuous time signal is represented by xt, where t is the time or independent variable. This is the difference between representation of continuous time signal and discrete time signal. Now I will plot discrete time signal using a continuous time signal. So this is an example of continuous time signal, this form. Now as we are plotting a discrete time signal, you should consider that the signal will be occurred at particular time interval. Let's signal xt will occur as this by 0.2 time seconds. Here time in form of seconds. So at 0.2 seconds the value of xt is this. Similarly, again that signal will occur at 0.4 second by this pulse. It is the value of xt for 0.4 second time interval. Again it appears as this line or this value at 0.8 second time interval, and then it becomes 0 at 1 second, or it appears as 0 in 1 second. Again it appears by this line at 1.2 seconds. By this way the signal will appear at every particular time interval. So if we plot these signals only, it is denoted by this line, this corresponds to this line, this corresponds to this line, this corresponds to this line. Again it becomes 0, then this, and again it becomes 0. So you can see that in between 0.2 and 0.4 seconds signal is not specified for discrete time signal. That means the amplitude of xt for this time interval is 0. Hence we can call as it is a discrete signal. Similarly, we can draw the discrete signal for this continuous signal also. Suppose the signal xt will appear as this value at t equals to 0. Again it will appear at t equals to 0.1 by this value, and then it becomes 0 at 0.2 seconds. Similarly, in the negative side the signal will appear, xt will appear at minus 0.1 second, and then it becomes 0 at minus 0.2 seconds. So if we plot this discrete signal only, it will become this, then this 0, again this and 0. Now you should remember one particular thing in this case, that for a discrete time signal in the y-axis you should represent xn instead of xt, and x-axis will be represented by integer n instead of t. Similarly, here also the same rule is applied. This is for today's lecture. In the next class, we will talk about some more properties of continuous and discrete time signal. and after that we will move to some other type of signal called deterministic and random signal. Thank you.